Appreciate all the viewers coming on to this webinar today to learn about new technologies for the manufacturing industry for today and into the future. Here's our agenda for our presentation. The focus of our presentation today is to share new technology with next generation Wi-Fi connected assembly tools that can provide real quality benefits to you as manufacturers of heavy vehicles and equipment. While you're watching this presentation, you'll likely be able to relate to some of the challenges encountered when manufacturing your products, and you might wonder, how can you implement this new technology in your company? Please know that Applifast can help you with this integration, as we also provide the necessary upstream and ongoing sales and service support to ensure successful implementation at your facility. During VTC's webinar in December, Ron said that he had noticed during meetings with manufacturers in the industry that a common issue was employee training for critical production tasks. In today's presentation, we're also going to demonstrate how Wi-Fi connected assembly tools can reduce that need for operator training and the costs associated with it while ensuring production of high quality vehicles and equipment. So a little bit about Applifast, who we are. Applifast supplies tool and fastener systems to the heavy vehicle and equipment industry. And while we supply some of the most basic forms of manual riveters and click type torque wrenches, we also supply and support the most advanced fastening systems and lock bolt technologies used in heavy trucks and on-highway and off-highway trailers, and locomotives, train cars, and rail systems, as well as mining equipment. And of course, in transit bus and highway coach manufacturing, which is what we're about here today, as well as all types of agriculture equipment, whether it's headers or planters or tillage equipment, and even in commercial or defense aircraft. And we actually work in space exploration too. So Applifast has been serving the manufacturing industry since 1974. We're based in Winnipeg, and we're honored to have a long-standing relationship with most manufacturers in Manitoba. And in recent years, we've made renewed efforts to serve manufacturers all the way across Western Canada with the same expertise and passion. We have lots of passion for this industry. In situations where our customers of US facilities, we travel to them and support them remotely as if they were local. So if you're at distance, that's no challenge. We're known to provide quality products that can be relied on. And through the years, we've also closely followed industry trends and have embraced new technologies, investing the time and resources to bring those advancements to our customers. In 2020, we refocused our energies to further define ourselves as leaders by concentrating on the fourth industrial revolution, known as Industry 4.0. We've also introduced new capabilities in rivets and riveting, as threaded inserts, complete with new installation tooling as well. So our team is excited to help anyone overcome their manufacturing challenges, and we only succeed when you succeed. So I'd like to thank the New Flyer Group for their reciprocal support of Applifast as they authorize the time and support of their staff and facilities for this presentation. I'm sure that everybody on the call knows New Flyer. Well, New Flyer acquired Motor Coach in 2015 and has since acquired other leading coach manufacturers, Arbach and Alexander Dennis, Plaxton, as up here on the slide. As a global producer of vehicles that carry passengers, they understand the responsibility to manufacture world-class quality products for everyday safe transport of persons like you and I. Today, they're focused on all their safety critical applications, and Applifast is New Flyer's partner to implement DC electric tools and accessories in all their facilities. In our presentation today, Sheldon Schultz of New Flyer's St. Cloud, Minnesota plant will present a working DC tool system, and Lance Mladinsky of Motor Coach Industries in Winnipeg will also demonstrate a DC tool system with operator guidance and process control. So in case you're wondering, I'll also be explaining what a DC electric tool is today. So a DC electric tool is a reliable torque and automation fastening system engineered for precise, accurate, and repeatable torque control. These high-performance fastening systems allow manufacturers to optimize the assembly area, reduce labor costs, and increase productivity. More specifically, A DC electric tool has a transducer and a resolver. Now here's where the transducer is in the tool and a resolver. The transducer is measuring torque and the resolver measures angle. The DC electric brushless motor is programmable, so we can set multiple speeds throughout the rundown to accurately approach and achieve target torque. And this gives us our repeatable fastening results. So we start the fastening process with the tool's trigger, but typically operate in an assembly process mode that is initiated with barcode scans. Fastening results are displayed to the operator with the onboard OLED color display. And audible beeps can be activated to warn or confirm the operator at the end of the fastening cycle as well. So when they've achieved torque, the results are sent via secure encrypted Wi-Fi back to the controller and onto the database if it's connected to a database. That gives you an idea of what a DC electric tool is when we're speaking about them in detail further on. Let's take a look at the range of assembly tools available today to explain why DC electric tools are so much better suited for critical fastening. The basic impact wrench is a commonly misused tool. It's not an assembly tool. Impact wrenches do not have torque control because they're dependent on air supply and operator skill. The pulse tool is also dependent on air supply, pressure, volume, and cleanliness. And joint conditions also affect the output of a pulse tool. So we often will encounter over torque or under torque failures. The first successful step users can take to control torque is with basic click wrenches, and Applifast does supply these. However, it is a slow manual process with ergonomic risks, when we're pulling high torque values. And torque wrenches do not provide data. So if you're pre-torquing with an impact wrench and finish torquing with a click wrench, you may be over torquing with the impact wrench and confirming you've met a minimum value with a click wrench, but how do you know if you haven't over torqued that hardware? So the next step in torque control is to use shut-off clutch nut runners in the pistol grip or right angle configurations. The challenge with these tools is that we have to order a specific model for a torque range and an output drive size, as well as they have one speed throughout the whole rundown process. So it's hard to achieve torque control in varying joint conditions. And when there's changes coming to the production line all the time, I want you to build multiple products. I want you to change the torque value. It's not easy to do with pneumatic clutch type tools. So the optimal tools for manufacturing are DC electric tools because we can program the tool's direction of rotation, its speed throughout the whole fastening cycle, and its output parameters with torque control and angle control. So this actually allows us to achieve joint monitoring for each fastening cycle. With the added error-proofing accessories, we can minimize operator training, any basic instructions, and these error-proofing accessories, you can produce a high-quality finished product. The software and operator instructions are also part of the operator guidance that is going to be demonstrated today. So this slide shows that Desoutter offers a complete range of DC electric handheld tools. The handheld tools here and the fixture tools here. Handheld tools, pretty explanatory, and the fixture spindle tools are typically mounted in torque control arms, which we're going to see today in Sheldon's video. Or we use them in a fixture where we have more than one spindle, so we can do multi-spindle synchronized fastening. Of course, quality assurance tools are an important component of advanced fastening systems, which we're going to present in a future webinar. The important thing to understand here is that Applifast offers a complete range of Desoutter products to torque from 0.3 Newton meters up to 1900 Newton meters to set up and establish any manufacturing facility with the tooling and accessories you need to build a quality product. If you don't use the correct fastening tools, you will experience failures in production or in the field, which brings us to the topic of our first video on a wheel assembly failure. So we're going to play this video here. Are you confident that your vehicle and others sharing the roadway have been assembled or repaired with the utmost care so that everybody will make it to their destination safely each and every day? We all saw that wheel hit the vehicle there.
OPP say one man is dead after a wheel assembly from a tractor trailer flew off and struck his van on the Queensway early this morning.
Now, what we do know is that the driver of a tractor trailer was heading westbound on Highway 17 here near Carling Avenue when a dual wheel assembly set detached. OPP say the wheels jumped the median, it struck the van, and it ripped off the roof, killing the driver. Now joining me here is Constable Booth, and he's going to explain some of the charges that have been placed in this case. So why don't we start with the driver? What has he been charged with and why?
The driver is driving the vehicle that was involved in the incident, so as a result, he's been charged with driving a commercial motor vehicle with a detached part. The detached part being the whole wheel assembly which came off the vehicle.
And now we've also charged a company, and what have they been charged with?
Yeah, the numbered company from Ottawa has been charged with operating an unsafe vehicle.
So that's a pretty devastating video there. Brings awareness to all of us as manufacturers. These specific details are from the Ontario Ministry of Transportation, but we'll get back to the presentation. We want to come up with solutions to prevent these issues in the field. So there's a good reason to fasten correctly. All of us on this webinar are involved in the industry, and we're aware of the many challenges there are in manufacturing. As a baseline, we need to source quality hardware that meets specifications, and then we need to tighten them correctly. So this slide shows some pictures of hardware, new hardware that is defective right out of the box. Any lubricant or Loctite or thread locker will decrease friction during the tightening. So that changes the effect. We know that stainless steel hardware has galling issues. Split lock washers do not work. That's been proven many times. And deformed thread lock nuts, they pack the plating into threads, and prevailing torque increases while we fasten. So that changes the dynamics as well. If you get paint in your threads, that will also increase prevailing torque while you're fastening. And of course, anyone who's remanufacturing, we just remind them that new hardware should be used to achieve accurate torque values. That being said, we can also have catastrophic failures even when good quality hardware is used, but it isn't tightened or installed correctly. So besides the video we watched, these pictures re-emphasize the adverse effects of incorrect fastenings. We got missing hardware here. You see there's a missing nut. We've got yielded hardware from over-torquing, so this may not have been evident during installation, but failed in the field. We've got over-torqued and broken hardware causing critical failure. I actually took this picture at the side of the road last year. It was apparent that the wheel studs had been over-torqued, and this happened at high speed on the highway. The wheel was gone, and the wheel studs are broken. This one here is a stripped hardware, so not aligned correctly. We've got galling again, excessive shear loads from too much force in this fastening connection. And then this fastener here failed from fatigue because it became loose, maybe after joint conditioning. So some of these issues are going to get through the production lines undetected without the use of DC electric tools. So if you want to fasten your safety critical applications correctly, glad you're here today learning about DC electric tools. This will prevent you dealing with warranty issues. It'll strengthen your brand, and it'll prevent that worst case litigation from loss of life that we've just seen in the video. Now that we've talked about all the pains, let's talk about the solutions together. This brings us to the video that we have of Sheldon Schultz of New Flyer presenting this DC torque tool system. In the picture, you'll see we've got a DC electric tool here. This is mounted in a torque control arm, and we've got the controller nearby for the operator to see in the workstation. This system is installed at the New Flyer facility in St. Cloud, Minnesota. So the operator is going to scan some barcodes to initiate the process because it is interlocked at the end of each completed assembly. So I'm going to warn you that there's some real life background noise in this video. So we've included closed captions so you can hear what Sheldon is saying in the video.
Hello, I'm Sheldon Schultz from New Flyer Industries. I'm here to talk to you about DC tool technology that we've been implementing throughout our organization at New Flyer for over 4 years. We use DC tool technology to hold tight and tightening parameters, collect and archive data results into our process, and we also are able to control torque and angle parameters. We have all of our safety critical installs set up this way. And right now, we're going to be using a GCI articulating arm with a Desoutter brand controller and a Desoutter branded tool to tighten our radius rods on an axle. So I'll hand it off to one of our assembly techs, Chris, and Chris will go through that process. So right now, Chris is scanning our collection data, which is our assembly process employee badge, and also we collect the serial number of the axle. So Chris is releasing the brakes on the arm right now. The arm is suspending the tool for proper ergonomics and weight, and it'll also absorb the reaction forces of the tool. So as simple as that, Chris has already got one of the 4 fasteners tightened with a green light. And you can see on our tool controller, we have 2 of 4 completed. To complete the assembly process, there's number 3. And there's number 4. So we've completed our assembly process. All 4 assembly actions were completed. That data will be stored in our data archive in our server.
Thank you, Sheldon. That was a great video. Thanks for the accolades there at the end. So I know you're on the webinar, and you put a lot of effort into that video, Sheldon. So that was great. We could all see how Chris scanned the 3 barcodes in a specific sequence, which allowed him to initiate the assembly process. And then the tool kept displaying green lights, which confirmed that he performed all 4 in the batch accurately. So the torque arm really helps with the proper ergonomics for the operator, because it balances the tool and absorbs all the reaction force from the tool, which is super important. And that particular torque arm also has enough reach to swing around and fasten the rear axle bunk assemblies too. So there's added value there for New Flyer. And I think everybody would have noticed that the tool is extremely quiet. We also saw that the tool was only applying the small amount of fastening at the end of the cycle there. And the tool can do full fastenings or it can do finished torques, and it does it all repeatably. It does it quickly as well. We can achieve the accurate torque and angle target with the DC tool. I think it was only 1 minute to do those 4 fasteners, and then it displayed on the tool and on the controller to provide the feedback to the operator so he knows where he was during the assembly process. And then at the end, you would have noticed there was a little stop sign appears on the controller screen. And that shows that the system is interlocked until the next axle build comes into the workstation and the operator scans in barcodes to start the next axle build. So that's helpful for the assembly process as well. So this brings us to our next video with Lance Mlazinski of Motor Coach Industries in Winnipeg. This is a longer video. It's about 11, 12 minutes, so bear with us. It's very interesting. Lance starts off his video with an introduction, but I'm going to tell you that demonstrating another Desoutter DC electric tool system that Applifast supplied. However, this system includes operator guidance. So operator guidance guides the operator throughout the assembly process for all torque related and non-torque related tasks. These airproofing accessories, any operator could safely build a quality product with minimal training. So we'll get this video started.
Hi everybody, I'm Lance Mlazinski, Manufacturing Engineering Manager and Senior Technical Advisor for Special Processes here at Motor Coach. One of my responsibilities is to take care of nearly 50 DC tools at both the Winnipeg and Pembina manufacturing plants. Why don't we get started? I'm going to give you a quick walkthrough of the system I've got beside me here, starting with this tool. This tool is exactly the tool that we use in Pembina, North Dakota to assemble our junction boxes, including electrical connections for all of our coach models. And after this demo, this tool is destined for our inspection pit, where it will re-torque charge air cooling clamps after road test. That tool is Wi-Fi and it's connected to this controller. Controller is where all the programs are stored and can be called up, and we'll show you how to do that in a few moments. But each of those programs can vary between the torque range of any given tool that you're connecting. After that, we've got an industrial PC. This is required to provide operator guidance. So the programs and the pictures, the content, all resides on that industrial PC, and there's constant communication between the PC and the controller and the tool to keep everything in sync of what's being displayed to the operator. Below that, we've got a basic pick-to-light system. There's red indicators telling the operator where to pick the parts, and sensors inside each bin to detect when that operator's gone to the correct bin. After that, we've got a few things like mushroom buttons to continue different processes that aren't torques. We've got a crane pendant here, a wireless crane pendant. We'll show you how that works. And as part of the process, the operator's got a couple build stations here to help the process. After that, we've got a electronic socket tray that has sensors inside to show when a bit's been removed or a socket, and also to indicate by a flashing light to prompt the user to use that particular socket. After that, we get to a barcode scanner. This barcode scanner is used to scan 3 different barcodes, including the coach serial number, the process that you want to build, and your employee badge. And all that data is stored with a database for every torque value that you perform. Okay folks, let's build a coach. I'm going to start off here looking at the last splash screen of the previous process, and it gives us a little indication here. We need the barcode scanner and scan 3 barcodes: coach VIN, assembly process, and associate ID. So this is the associate ID, and right here is the coach VIN. So this would typically travel with the coach. We'll start there. And the second one, we're going to build a coach. Scan that. That's been accepted here on the screen. Scan my employee badge. All right, that's been accepted. And the first thing we see on the screen is the finished product. So it wants to confirm that, is that the correct barcode that you scanned? And we can acknowledge that by looking in the corner here and pressing a button to continue. So here we go. Okay, so first things up, our bin light's on, and inside the bin there's a sensor that's going to detect my hand and increment the picture to the next step automatically. So the first thing it's saying is load chassis into fixture as shown. There we go. Press button to continue. And next bin, next part. So we've got some bearings to pick here. Quantity 2. Got those out. Place bearing on chassis as shown. Okay, here we go. Got that. Press button to continue again. Okay, now we're picking some wheels. Bin lights on. Something to notice here, large diameter, small diameter. Okay, we'll take a look. Got 2 different size bores in this wheel. Okay. Place wheels over spacers with larger diameter facing up. Okay, got that. There we are. Okay, press button to continue again. Okay, pick wheel bolts. Quantity 2. Thread each wheel fastener into chassis by hand as shown. Okay. There we go. Got that. Press button to continue. Okay, so now we're showing a tool in the corner here, and it says select bit from holder as indicated by flashing light. Oh, there's our flashing light on the bit tray. Pulled it out, indicates it's gone, and we're going to put it on the tool. Okay. We've got a blue light here showing our tool's connected to the Wi-Fi and not sleeping. So we'll try and do a torque here. Okay. I'm holding the button down until a complete torque is finished and a light shows up. Then I can release the button. Okay, so thing to note here, we got a good torque and a good angle. You notice the torque and the angle are both very, very small. We're dealing with pretty rigid parts here that don't have any give at all. So we can expect a very low angle. I'll do another torque. There we go again. And we got another green torque. Okay. So we'll pull this bit off and put it back. Okay, place that. What do we have to do now? Roll chassis and fixture as shown. All right. There we go. Press button to continue. Okay, we're picking bearings again. Place bearings as shown. Press button to continue. Got some wheels to pull again. That's good. Okay, press button to continue again. Pick wheel fasteners. So I tested this system on a half dozen colleagues in my office, and they all were successful in building this truck. So basic picture with small amount of text and some little indicators. Tells the operator what to do next, and here we are, we got another bit flashing, so we're going to take that one out. There we go again. Should note that the speed that we're using is set in such a way that it can handle these hard joints that we're dealing with here. So every single parameter in the tool is configurable. We can configure torque, We can configure angle and the speed of rotation and a multitude of other things that you can get into when you really get experienced with that software. Okay, so we're ready to do a move. So you can see that time the picture incremented by itself based on the results of the torque being green. And now we're going to go to the next step. I'm going to place this frame on the next fixture and press continue. Okay, so now we're picking the shell. Pick that. There we go. Place the shell on the chassis. Continue. Some shell fasteners. Drop bolts into shell pockets. Okay, got that. Continue. Thread each fastener and chassis by hand, 2 turns each. Okay. There we go. Okay. All right, so it's indicating to pick the tool up, grab another bit. This is the other bit this time. Place it on the tool. We're doing 2 different torques here, so that the torque program has automatically changed. We're doing a totally different torque this time than we did last time, and totally transparent to the operator. No setting, manual click wrenches, just pull the trigger, wait for a green light, and move on. Okay, we'll put that back. Okay, we're picking a cab this time. Get into the cab bin. Place cab on chassis as shown. Continue. Pick fasteners. Okay. There we go. Drop fasteners into cab pockets. That's done. Continue. And we're going to hand tighten these guys a couple turns. Okay, good. Press button to continue. All right, we're going to torque again. Back to the socket tray. Get on there. Okay. There we go. First torque's good. And second torque. Identical angle on those 2 fastenings. Okay, put that away. Okay, so basically we are complete our assembly process. Now we're just going to pretend to crane this off of the last fixture. I kind of added this in here because I wanted to kind of illustrate that you don't have to be kind of tied to a bench. You can be out in the shop in a large area doing a weldment or following weld instructions or working on a large coach with a 50-inch TV up on the wall. And you can have this on your belt and you can press these buttons like indicated here, start and up, and you can process through the steps of the instructions. So we just completed the first coach build.
Oh, that was great. That video always makes me smile, Lance. Thank you again for your effort in putting that together. It was a lot of effort to do that, but really demonstrates well how the DC electric tool system can guide an operator with operator guidance and interactive digital work instructions through a complete assembly. The pick-to-light system and the socket tray is an ideal way to error-proof, so it eliminates defects in production. I like the red lights on the bin. They really did a good job of guiding you to the correct parts and helped you follow the sequential steps as necessary. So in this bus build, we achieved 0 fault production because we did not have any missing fasteners or parts. We applied the correct torque each time, and as you mentioned, the tool does that automatically. So it's pre-programmed, and when you select the right bit, the torque value changes automatically. And then you kept following the sequence until the build was complete. And the good thing is we get traceability for each fastener, which includes the operator's name, the date and time stamp, and every other detail that went into the process to build that VIN. Now, Lance and I are going to take you out on the production line at Motor Coach in this next shorter video. And we're going to learn more about Motor Coach's journey with advanced fastening systems and why they rely on them every day of the year.
So we're here at Motor Coach Industries out on the production floor after hours. It's great to be up close to the legacy D-Coach that we've seen on the road for years. Lance, tell me, how many years have you been using DC electric tools here at Motor Coach?
At Motor Coach, we've been using them since 2012, and I've been here for 6 of those years.
Evidently, it's brought you up close to a lot of applications that DC tools are used in. For our viewers, can you tell me, what are the key benefits of using DC electric tools in production?
Well, I guess first of all, it's their capability to trap errors. So we can catch a lot of things before they leave the facility, even before they leave station. So having that traceability in the database, the torque control, and everything that goes with it is some of the best advantages of DC tools. And right in front of us, we've got one of the DC tool stations here again. This one does our axle installation fasteners for radius rods and items like that. And right here is the key example. We've got the operator guidance there. So it helps new operators, it helps old operators keep on track. It doesn't matter if they go on a coffee break, come back, they know exactly where they're at, and we don't miss any steps. And that's the key to a quality product.
That's great, because you do build a quality product, and having these systems in place out on the production floor, in station, they can provide that service for any manufacturer. I see that you've put a custom reaction bar on this tool to suit a unique application. That's an excellent job that you've designed that as well to make the tool function in close clearance applications.
Yeah, this particular fastener was very difficult to reach. The operators had a very hard time, and it was a high torque application too. So having this special reaction, and the operator now just have to get the tool into position and press a trigger instead of trying to roll a torque up to 200 foot-pounds. It's a huge advantage, and the operators love it.
So that's great, because it's preventing you those ergonomic risks as well. But I think that you go to a lot of effort to make these tools usable in production because of the benefits they bring you in the way of quality. There's a big benefit of producing a quality product with DC electric tools.
Absolutely.
That video, you could hear Lance reiterate why Motor Coach relies on DC electric tools every day in production. That was great. They can trap the errors before any assembly leaves a workstation or before the bus leaves the plant, which ensures they always build a quality product. So the DC system provides full traceability, as we've heard, for every fastening cycle, and it's stored in the database, which is networked at New Flyer. Of course, torque control is very important, and operator guidance is huge to help minimize training and maintain confidence that they're building quality buses, and keeps the operators on track, as we heard, even if they go for a break. So having a power tool that prevents ergonomic risks is also a big advantage. It prevents them torquing manually, as Lance said, rowing up to 200 foot-pounds. Saves you those ergonomic risks as well. So again, we're going to have another short video to continue our discussion on the production floor and get some insight into why torque and angle control are so important. Next video.
Lance, in our presentation today, you've talked a lot about torque and how important it is to achieve our target torque values. But we've also talked about angle targets and how do we achieve angle parameters within certain windows. For our viewers, can you give me an example of why controlling angle measurement is so important in advanced manufacturing?
Sure, I can do that. Actually, I can give you 2 examples. The first one would be probably a cast part that's got threaded holes in it. And if it goes through a process that's where that part is painted before reaching the production line for assembly, there's a chance that you can get paint in those threads. If that happens, the angle measurement that you're going to get with the DC tool will be different than your typical non-painted threaded expectation. So in that case, you basically would reach your target torque earlier than you would with clean threads, and then what that means is you actually have less clamp load. Clamp load is really what torque's all about. That's what holds everything together and keeps everything going down the road. So it's super important in that case to set your parameters for angle. If you reach a target torque early because your angle is low, that can give you an indication you've got cross thread or paint in the threads or something like that. Another example would be two different types of lock nuts getting into the same bin. One's got a prevailing torque, which is the torque just to get the nut down the bolt thread without even doing anything to the joint, of say 10. And the next one's got 20. So all of a sudden, that's a considerable amount of prevailing torque that will affect your clamp load again. So here you are. You can set your tools to detect all those things and prevent escapes to the field.
So applied torque, subtract my prevailing torque, has an effect on my clamp load or preload in the joint.
You're getting pretty technical, Brian, but that's great. That's exactly what's happening.
That's very interesting, and I'm sure a lot of viewers will have witnessed this at some point. But there's another scenario where our angle measurements, we could go beyond our angle parameters. In that case, we might be missing a component in the assembly. In that case, we might have stretched the fastener too far because of a change in our friction value. So maybe we lower friction and we increase the angle it takes. We'd pick up on that failure with a DC electric tool.
Absolutely. Lubricated, non-lubricated threads would cause that. Another one would be reusing fasteners. When you reuse a fastener, you actually condition the threads of the nut and the bolt, and your clamp force actually goes up when your threads are conditioned. It changes the joint completely, and you could be into the yield point of your fastener at that point.
So it's very important to have controlled hardware coming into the station.
Exactly
it's very
right.
important to have our plating types remain the same. It's very important that the threads aren't damaged before we use the product, right? So when it comes packaged, it needs to be packaged correctly. There's a lot of things that go into upstream, but we find those issues when we're using advanced fastening tools because they tell us about what's going on in the joint.
Lance's examples were excellent as they provided some real life situations that explain why torque and angle controller is so important. Remember, the whole objective when fastening is to create clamping force. So as explained in the video there, the friction or prevailing torque that we experience when we're running the nut down the threads of the bolt is taking away from the amount of applied torque that goes into tensioning the bolt. So maybe you have experienced paint in the threads of your parts and it affects the products that you build. Maybe your supplier's been short of the standard nylon lock nuts due to COVID and has been supplying you with deformed thread lock nuts instead. As Lance mentioned, if you change the lock nut types and experience an increase in prevailing torque during the rundown, it will equate to a lower clamp load with the same torque applied. Conversely, in applications where friction is significantly reduced with a lubricant, could be a liquid Loctite or a thread locker, and you continue to apply the same amount of torque from a conventional tool, like a torque wrench, you could actually be tightening your fasteners beyond their yield point and could cause those fasteners to fail in the field. So this slide on the left side, we show an example of how hard joints and soft joints act differently. A hard joint is a fastening together of two components or parts that do not compress easily. So the fasteners begin to yield much sooner and the angle required is considerably lower. This is typically a joint consisting of thick metal to metal components, and that is shown here. I'll get my pointer up. This is a typical hard joint condition, metal to metal, no give in this joint. But a soft joint contains parts that compress easily. So we got some kind of a gasket material between. In this soft joint condition, the fasteners begin to yield much later and the angle is considerably higher in value. So imagine a thin metal component, gasket, being attached to another piece of metal. You're going to experience a soft joint condition. So you can see in these angle measurements here, we can go from 5% to 100% of target torque in less than 30 degrees in a hard joint condition. In a soft joint condition, we have to turn that same fastener 2 times to achieve 100% of target torque. So this is kind of explained roughly in this graph here. You can see a much shorter angle curve on a hard joint condition than a much longer curve on a soft joint condition. On the right side of the slide, we've got different types of joints here pictured. So we've got a screw type joint going to a blind hole, a bolt and nut assembly, very common. We're gonna have a wrench on one side and the tool on the other. And then we got a stud application, again, a different relationship here. So I'd like you to think about what types of joints you're working with in your products. Do you find that your fasteners relax after you've tightened them the first time? Maybe it's after you do a run-up test. You'll notice a relaxation. You might notice that difference that we've mentioned with the thread locker. You apply that to the threads and it feels like it's tightening easier. That is because the friction is lower and you're applying more clamp load. Maybe you've also experienced that galling in stainless steel hardware and you tighten the nut, it jams with the bolt and the whole thing starts turning in the hole. So as strange as it may seem, any changes in these joints, so even if we're using one type of hardware in a joint and someone comes along and changes it, the plating type, or suggests using a different length or changing the head style, all of these things can change the final clamp load in the joint. And even going from fine thread to coarse thread makes a change. So the good news is, whatever those changes are, we can accurately control the parameters in the tool so that we can overcome those changes. That's with DC electric tools, these advanced tightening strategies. We got torque control, angle control. We can do torque and angle control, torque or angle control. There's many different strategies. But this colored picture on the right side shows how the tool reports on the result. So the aim is to get the result, the tool to stop within this green box here. So we're setting these parameters for torque, we're setting these parameters for angle in the programming screens. You can see here in the backdrop, there's a programming screen. You can see this is what a typical oscilloscope graph would look like. That is what we're trying to program for. In this screen in the foreground of this slide, this is a results screen from the database. You can see how this curve with the red arrow is much different than the numerous correct curves that we've got here represented by this green arrow. So this is what the curve should look like. This one here has had a difference. So this could have started angle early because of paint in the threads, as an example. So in this next and last short video, we're going to be talking further about this data that we receive from each fastening cycle and how we understand what that data represents.
So when I say telling us about what's going on in the joint, there's these traces or curves. We call them a torque over angle or torque over time. We can compare the data bits in many ways, but we get 1,000 data bits from every fastening cycle, Lance. Tell us, how do you analyze that data to adjust parameters in your existing applications or even when you're designing new applications with engineering?
Right. Well, engineering's got a basic requirement for the clamp load required, how many pounds of force required to hold that joint together. And then they select a fastener based on those parameters. And at that point, you can start doing tests with a DC tool. You can torque those fastenings multiple times using new hardware each time and get a whole bunch of data on angle and traces. And you can watch these things and do statistical measurements and calculations in the database, which it does it for you actually, right afterwards, and set your angle limits so that you're matching the capability of your fastening joint. And then when it goes outside that, you've got a problem.
Very interesting, and thank you for mentioning the database again, because these curves are stored for every fastening cycle, aren't they?
They sure are, yeah. We often refer to those sometimes when we're having problems, sometimes when we just want to prove that, you know, we're on track.
Yeah, so you can go back and make sure you're maintaining those original parameters that you initially set.
Exactly.
That's very important.
Well, thanks for coming to Motor Coach, Brian.
Thank you, Lance. I really enjoyed the opportunity to work with you and put this presentation together for our viewers. I'm sure it's going to be very meaningful to them.
Last video for today's presentation. We'll touch base on a few of these details about the database, and you can see it's very important that New Flyer has a CVI NetWeb database installed. It's a huge benefit to them in many ways, as Lance has already explained. All the results can be made available to any authorized user to view on a web-based device that can access the database from the production floor. So this will give you the visibility to confirm if your operator's torqued each fastener on a particular vehicle or product that you build. It'll also give you the final torque values. So the controller itself will store 10,000 results. The database actually is an ongoing database. It updates every 10 seconds from all controllers that are connected to the database. So it gives you real-time access to the fastening results, including the curves that are so important to monitor and measure. This data can all be filtered, queried, and reports can be processed. The full statistical analysis, you can see here on the screen, we've got some statistical analysis and a Six Sigma representation. This database shows a nice green results screen. Everything is going well here. Oops, this database screen shows that we've got some issues happening here. What's going on? Well, they can't move on until those reds or yellows are overcome. So you can see, you can drill into each line and row and filter, create reports of this information. It's very powerful, and it obviously makes the whole system successful for the manufacturer. So next slide. As Desoutter creates trends in the marketplace, they also make advancements to their full suite of software. We use CVI config to program the equipment, including all the network configurations for the Wi-Fi tools. We write our parameter sets here in our assembly process controls. In Monitor, we use this software to remotely monitor fastening results in the production line or when we're setting up new tools as it happens. So that's, again, real time. And then engineering typically is using the CVI Analyzer software to drill into specific case study fastening results offline. But CVI NetWeb also has many of those capabilities. So if you're already at phase 1 or 2 in the journey here with torque and batch control, so torque control first, and then we can start doing batch control for your standard joints, you're on your way. From there, we can go through joint control and station control for quality critical and safety critical joints. This can take some time to implement for sure. As you can see in Sheldon and Lance's videos, they've put in tons of time to make this successful. While they might be at different phases too, both of them are making great progress towards achieving zero fault fastening. The ultimate goal, of course, is to get to line control or plan control, but no matter how you proceed on your journey, we're here to help you make progress. All of this equipment from Desoutter has made Industry 4.0 advancements achievable in manufacturing. Here you can see a brief introduction to our Connect Desoutter Connect ecosystem. This has been developed with flexibility in mind for factories of the future where change will happen by the hour. Data-driven solutions are the future and will be part of your Industry 4.0 journey at some point. So Applifast represents Desoutter Industrial Tools in the marketplace, and we use Desoutter tools and accessories in our presentation today, so I wanted to introduce them to you as well. They're a global company that is over 106 years young, and as a company with a highly innovative spirit. Their headquarters and manufacturing facilities are in France, and they maintain customer centers and service operations with 1,500 employees in 50 countries around the world. So one amazing thing about Desoutter is their efficient international distribution center in Europe. They ship goods to us by air freight, and we receive them 3 to 5 days later. So they're leading the industry with their DC electric tools and softwares and accessories that will help manufacturers like you reach your Industry 4.0 goals. So to summarize, Applifast can help you overcome issues in your manufacturing environments and gain the advantages that DC Tools provides you. We touch on all the points we've talked about. Again, the slide will be part of this presentation. Understand that Applifast has the experience and technical expertise to help you do this in your facility. So to deliver you the best solutions, we're asking to please bring us into your problems as early as possible. It's beneficial that you contact us early in the process so we can assist you with the design elements that otherwise might become missed opportunities later on in your process. We also provide a complete solution. So from the initial concept to installation of the equipment and training, we call that a smart start, right through to the annual calibration and preventative maintenance of your DC electric tools. Applifast is here to help you. Once again, I want to recognize Sheldon Schultz of New Flyer in Minnesota and Lance Mlajinsky of Motor Coach in Winnipeg for their time, effort, and ongoing support. I really appreciate that. And also want to thank Ron Vanderwees of Vehicle Technology Center for bringing us all together today to advance the use of technology in manufacturing heavy vehicles and equipment. So Ron, back to you.
All right, thank you so much, Brian, Lance, and Sheldon. Now is the time for questions and answers, and basically look into the Q&A feature here on the webinar. We've got a couple of questions up. I'm going to start with one is, let's say that I'm a manufacturer, and oh yeah, I should ask Lance and Sheldon to turn on the cameras and unmute themselves as well, so you guys can meet them. So I'm a manufacturer and I want to identify which vehicles that I'm torquing wheels on, and I want to keep that in a database using a connected tool similar to what you've presented here. What magnitude of money would I need to set up a single assembly line with a wheel torque installation? I'll leave that's to Brian.
Thanks, Ron. It's a big question because there's a lot of variables to that answer. But if we could talk about a single spindle, so one tool and a cable and a controller, the tool is going to be somewhere in the neighborhood of $10,000, but a complete working system in the neighborhood of $25,000. So of course, you can take that many ways. You can attach multiple tools to a specific controller with the wireless technology, so it brings all those costs down. But really, we have to look at what's the return on investment in our factories, and there's many aspects of that value analysis too, including what are the risks of not doing it. So hopefully that gives some insight. Yeah,
and $5,000 a wheel off, it pays for itself pretty quick if you're having to deal with fines, right? I'm going to ask Lance this next one. This comes from Blair Hamilton. The demos have focused more on production line rather than a maintenance line. How portable is the equipment, say for field engineers or maintainers of assets on a work site? And I noticed in that last couple of videos that your setup was actually on a cart.
Yeah, that's right. That's right. And one addition that you couldn't see just out of the frame of the video was a UPS. So we typically will set up these systems with uninterruptible power supply, and that way we can wheel them around the factory as needed. for whatever reason, out of station work, if we're have a part shortage or what have you. That way the tool can actually still perform the work we need to do. So that might suit someone that needs to haul this equipment to a job site.
Excellent. So is it possible, I'll ask this one to Brian, if I'm remote maintenance and I'm using these tools, can it store data and then upload data when I get back to my facility? Or do you have to be connected to Wi-Fi at all times in order to capture the information that you're generating?
So when we're on wireless communication, there's a limited number of curves that we can store in the tool because of the size of the package, the data package. But we can certainly store the torque and angle results and then come back into contact with the access point, and then that data transmits from the tool to the controller. And then if the controller is connected to a database, the controller transmits that data to the database. So the database is usually installed on a database server. So, you know, if you're doing something out in the field and you could take a tool and do the fastenings and bring it back within range of the access point and upload it, I think you would get 10 okay curves, 10 not okay curves, but you would get hundreds of torque and angle results, and those would upload automatically when in range with the access point again.
Excellent. Thank you. I'm going to ask this one to Sheldon. Can the software integrate with existing ERP software systems so that torque results can be recorded against equipment assemblies, etc., linked to electronic job cards? I guess part of the question is does the data reside in Desoutter, or can it be exported to vehicle files or vehicle specific folders? What's your thoughts on that?
So you guys saved the toughest question for Sheldon. I really think that I would like to defer this one to Brian. I know that there is some capability to use different fastening software systems via open protocol, but I guess I've really never had to use that. I've never had a system set up that way.
It's all good. Brian?
Thanks, Ron, and thanks, Sheldon. So yes, the answer is that the database is an SQL database and could be queried with any ERP system. It, of course, would have to be formatted according to that particular person's needs, but yet there's many ways of exporting the data from the database. Typically, the quality department or engineering or production is looking at the database, and they have, and we are going to do another webinar specifically on this. So whoever's listening should watch for that on the VTC webinar list. But to answer the question more clearly, you can create your own reporting, and that can be exported in Excel, PDF. There's several different formats that can come out of the system.
Okay. Excellent, excellent. So we're going to go back to Lance with this one. How long does it take to program and configure the steps in the software for the lights on the bins, etc., that demonstration that you did? You know, is there a significant investment in time required? Maybe talk about how easy pulling the documentation into, like, obviously you've got an SOP there that you hit the mushroom button and page through. Is that just commonly available software you would use to create that, or is that a proprietary Desoutter thing? Can you give us a little bit of insight there?
Yeah, the software running the operator guidance is called CVI HMI. It's just a software that they provide, and it communicates with the controller. In terms of time and effort involved, that particular truck build that we watched the video of was about 56 steps long. Taking the photos of each step and all that, and doing the programming. Honestly, the photos took longer to get on the screen than it did to actually do any programming. So the overhead to set that whole system up was like a few days. So not long.
Okay, interesting. Yeah, I can, you know, you think about the current process today where usually a log travels with a vehicle, and the log will state that this particular bolt has to be torqued to 85 foot-pounds. The only guarantee you have is you know who did it and that it's at least 85 foot-pounds if it's done properly. Whereas with the tools that have been presented here, you can actually know that that was 87.2 foot-pounds of torque, how many rotations it took to get there. One of the questions I had was, if somebody were to slip a prevailing torque lock nut in with a bunch of nylock lock nuts, is it possible that the system could lock that operation out knowing that there's something wrong with that joint? I'm going to ask that to Sheldon. Does it have that kind of sensitivity? Like if you were looked at the angles and the loads, the torques, can it pick that up and actually lock that operation out?
Absolutely, yeah. So the prevailing torque of that particular nut is going to be outside the window of the angle that you created for the nut that you're using in production. So if what it would recognize it as being below the angle limit or above the angle limit, and you're controlling torque and angle, let's say, on that strategy. So it would reject it. And usually, like at New Flyer, we usually give it one retry, and if it's still outside that parameter, it's going to lock that tool out. Will not allow you to proceed, and it will not allow you to finish your assembly process. So we have all of our stations set up that way. So when that happens, it's going to, alert a supervisor or someone like myself to come over, unlock that tool to start asking those questions about what happened, and hopefully that leads you to we've had a change with this particular nut.
So let me ask you this: is between Lance and Sheldon, both of you guys, what's the most surprising thing that you were able to sense, or the most surprising thing you were able to learn through the integration of this technology? Maybe something that you didn't expect.
I could take
ahead,
that
Lance.
one.
Yeah.
Okay, sure. One surprise that I found was we have a stainless steel plate that's holding a lot of our some of our pulleys on the drive belt, air conditioning drive belt system, and we're torquing these, and strange things are happening. I can't really explain what was happening, but the end result was the tool was detecting that there was wax from a milling finish on the plate itself that we were bolting this pulley to. So the tool was finding it. We're detecting problems, but I couldn't explain why. But finally, by the time we root caused this, it came down to the finish of the stainless steel plate, which had changed, and all of a sudden the tool caught that. So very happy to catch things like that.
My goodness, that's sensitive. Wow.
I would just say in general, the surprising thing for me since we started this was when we first introduced these tools and started giving them to our production folks and get them in their hands, they were very hesitant and reluctant to want to use them. Why are you doing this complicated process? What is the reason for this, right? And you give it to them, and 3 months later, if you have one of those tools that's got gets sent taken out of service, let's say for calibration or any reason why that tool they can't use it for the day, they're upset. As soon as they start using those tools, they love them. They don't want to go back. They want to continue using them, and trying to go back to reverting back to the old process is something they're not interested in doing.
Well, that leads actually wonderfully to the next question here. Chad's asking, what are the differences in vibration between these tools and other options? Not exactly sure what the other options are. How does this help the team on the production floor? Like, I noticed that those tools are virtually silent. So there's more than likely not a lot of vibration. I would assume that there's a little less reaction torque because you're in control of how fast you're fastening. Is there anything else you can add to that? I'll fire that one over to Sheldon.
Yeah, I mean, vibration, it's kind of hard to quantify that, but I think, having one of these tools in a production environment, we want to make sure that they're not exceeding, let's say, I think our limit's about 80 foot-pounds, before we're going to add a reaction arm on there, so that they're able to hold that reaction force. Anything over that, we're going to want to put a reaction bar or mount it to an articulating arm. But the tools are very quiet, easy to use. You're not, having to, turn it manually. You're just pulling the trigger until it turns green. So it's virtually going from, a click wrench where you're manually turning this tool, having to set the tool, to putting the tool on the joint and pulling the trigger. So, vibration, I would say, it's minimal. It's negligible.
Yeah, I'd like to add to that too. In terms of the vibration, for the higher torques, a lot of times we'd run them up with an air tool, and that's where the vibration and repetitive strain injuries will come in, right? So when you don't have to do that, following your air tools, following up with a click wrench, you can just use the DC tool right from the start. And like Sheldon said, you press a button, you got no impact to the operator. Operator loves it, and it makes it easier on everyone.
Well, that's great. Thank you very much. I don't see any other questions coming through. So I think with that, we're going to end this webinar. Thanks to Brian and the team at Applifast. Brian's contact information is on the screen there. If you're interested in more information about Desoutter, thanks to Lance and Sheldon from the New Flyer Group, New Flyer MCI. And thanks to your company as well for allowing the time to be able to work with Brian in order to put together this presentation.